everyone, welcome back to my channel. It's your favorite interview buddy here, and I'm here again to solve an interesting question. If this is your first time watching any of my videos, welcome. I'm glad you are here, and I hope to see you again very soon. Please subscribe and hit the notification bell so you can receive notifications about my upcoming videos. Okay, let's get right into the video. So today we would be talking about the two-sum interview question. I got this question from Leetcode, the question and the examples, everything I got it from Leetcode, and Leetcode tags it as an easy question. So let's assume that you were given this question during a technical interview. What do you do? So I would suggest that you start by reading and understanding the question. Okay, let's do that. Given an array of integers, numbers, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So I've read the question. Now I need to understand the question by going through the examples and seeing if it actually makes sense to me. So let's go through the first example. So we are given an array of integers 2, 7, 11, 15 and a target of 9, and the expected output is 0, 1. Now let's see if this makes sense. So 0 here is 2, like element 2, integer 2 in the array, and 1 here is integer 7 in the array. 2 plus 7 gives us 9. So that actually makes sense. Okay, then if we go to the second example, we see that we are given an array of integers 3, 2, 4 with a target 6, and then the expected output is 1, 2. Okay, so how did they come about that? So integer of index 1 is 2 and integer at index 2 is 4. So 2 plus 4 gives us 6, and I'm sure the same goes for the third example. So after trying to understand the question and the examples, it would be a very good idea to reiterate your understanding of the question and the examples to your interviewer, so you know that both of you are on the same page. So the question already gave some assumptions and things we should just overlook. It says you can assume that each input would have exactly one solution, that there would always be one solution in the input, and you may not use the same element twice. You can return the answer in any order. It's always very good to keep these things in mind. And then we are asked to return the indices, not the numbers themselves. Always put the key points of the questions in mind. So after discussing the question with the interviewer and you've understood the question, clarify your assumptions. In this question, there's really nothing much to clarify because the question is pretty direct. So we've clarified the assumptions and all. Then you can try to come up with a pseudocode, like talk your interviewer through a pseudocode or an algorithm of how you think the question can be approached or solved. So in this case, here is how I would come up with an algorithm of trying to solve the question. So I'll be using example 2 because it looks like example 1 is pretty straightforward, like the first two elements are actually the answers. So that's quite straightforward. So let's try using the second example to come up with an algorithm. So let's assume we are giving an input array of 3, 2, 4 with a target 6. How would you approach this? So I would approach this by comparing the elements in the array against themselves until I find my target. So I'll keep adding 2 elements in the array until I actually find my target. Now, I would have to reiterate that this explanation is beginner friendly, because we'll try to come up with a brute force solution and then try to come up with a better solution. So I'm not going to jump into the efficient solution first. I'll try to reason through it, and then we come up with a brute force, and then we come up with the efficient one. So in this case, I start with 3, right? And then I'm going to try and compare 3 with, add 3 to other elements in the array and see if I actually get the target. So we start with 3, and then we try to go through the array a second time and say, okay, 3, but we're asked to only use one element once. You may not use the same element twice, so we are going to ignore 3, and then the next element is 2. Now 3 plus 2 gives us 5. Is that our target? No. And then the next element in the array is 4. 3 plus 4 gives us 7. Is that our target? No. So in this case, we go on to the next element, 2, and then we try to compare 2 with every element in the array. We start with 3. 2 plus 3 gives us 5. Is that our target? No. We continue. Now 2 is the next element in the array. Because 2 is what we are currently comparing, we skip it. Now 4. 2 plus 4 gives us 6. Is that our target element? Yes, this is our target element. Can we stop here? Yes, we can stop here, because the question says you may assume that each input would have exactly one solution. So we found our answer. 2 plus 4 is 6. So at this point, we can just return the indices of 2 and 4, and voila, we have our answer. So let's see if we can come up with a pseudocode based on the algorithm we described above. Based on this algorithm, we can see that it looks like we are going through our array multiple times, and within each loop, we actually have some conditions that we check to see if we found our answer. So we could say that we are going from index 0 to the end of array. Let's call this index, index A, and then we are going again from index 0 to end of array. Let's call this index B. And then remember that we check, is index A equals to index B, meaning are we on the same element? Remember the question says, and you may not use the same element twice. So if index A equals to index B, skip, because we can't use the same element twice. Else you go ahead and compare. So you now say, is number at index A plus number at index B equal to target? And then if yes, return index A and index B as an array. Else we just continue. So we've basically converted our algorithm here into a pseudocode, and this should actually work for all our examples. If we look at it, if we loop through, and if you walk through the algorithm, you'll see that this should work with all our examples. After coming up with the initial solution, which would most likely be a brute force solution, you then need to ask yourself, can my algorithm do better? Now, the initial algorithm we came up with was quadratic. Can we do better than that? Can we at least make our algorithm linear? So what makes our current algorithm quadratic? It is this inner loop. And then the question we need to ask ourselves is, can we get rid of this inner loop? To understand if we can actually get rid of the inner loop, we need to understand what the inner loop is doing. So let's go back to our initial example here. So this outer loop picks a 3. And then the inner loop here is actually trying to find another element that we can add to the 3 that will reach the target of 6. So you can say that the inner loop is trying to look for another element that is what? Target minus what we are currently seeing, minus elements in outer loop. So the inner loop is actually trying to find if the array contains another element that is actually target minus element in outer loop. And once it finds that, it returns. So can we make this search actually easier? Can we prevent our algorithm from going through the whole array to actually look for this element? We need to look for a data structure that could help us carry out the search that the inner loop is carrying out in constant time. 2 data structures come to mind: the dictionary, or what people call map, or a set. Now, in our case, remember, we need to keep track of the target minus element in outer loop and its index. Because remember that we are not returning the element itself, we are returning the index. So it's better we choose a dictionary or a map because they allow key value pairs. We can store both the target minus elements in the outer loop and its index. So definitely it's better for us to use a map, or as you might call it, a dictionary. So let's try to rewrite our pseudocode. So I'm just going to copy our previous pseudocode and try to create or initialize a dictionary in my pseudocode here. Now let's get rid of our internal loop. So in the internal loop, right, we say, does the dictionary have target minus elements minus what? Number at index A. If yes, it means we found the answer, right? Then you say index B is equal to dictionary dot get target minus number at index A, right? Then we can return index A and index B as an array. Now, if the dictionary does not have the element, so it means we've not found it. So we can as well record what we currently have now in the array. So we'll just we'll say dictionary dot put, right, current number at index A, comma, index A. I know this might be a bit confusing, but let me walk you through it. So using our example up here. So we have an array 3, 2, 4 with a target 6. Right? Initially, our dictionary is empty, right? And then we do our first loop of 3, right? Our outer loop, this loop here, we start with 3, right? At this point, index A is what? 0. Index A is 0. Our dictionary is still empty. And then we check, does our dictionary have target? Does our dictionary have target minus number at index A? Now, what's the number at index A? 3. What is the target? 6. Now, 6 minus 3 is 3. Does our dictionary contain 3? No. Like, does our dictionary have any key called 3? No, it doesn't. So what do? We put the current number at index A and index A into our dictionary. So our dictionary becomes our dictionary becomes 3, right? 3 and 0. Now this is our dictionary, and then we go to the second element. Remember, we go back to the loop, and then at this point the loop picks item 2. So we go to index A is now 1, and then we say, does the dictionary have target minus number at index A? Right? Now, what is target? 6. What is number at the current index A? 2. Does our dictionary have 6 minus 2? 4. We say no, it doesn't. So what do we do at this point? We do dictionary dot put number at index A and the current index. So our dictionary grows to this now, 3, 0, and then we can now have 2, 1. Now we go back to the beginning of the loop, and at this point our loop picks up the last element in the array, so which is 4, and then we have index A is now equal to 2. And then according to our algorithm, it says, does the dictionary have targets minus number at index A? Now, what is the current number at index A? 4, right? What is target minus number at index A, which is 6 minus 4? Does our dictionary have a key? 2. The answer is yes. Our dictionary has key 2, right? So what do? We get the index of 2 from the dictionary, right? So at that point, we're able to, yes, dictionary has target minus 4, right? So at this point, we can now say index B will be equal to what? Dictionary dot get target minus 4 is what? 2. Dictionary dot get 2 will give us 1, which is the value. So index B at this point is 1, and at that point we can now return 1 and 2 in any order. Can you see that we still arrive at the same solution? We still arrive at the same solution, but we've made our algorithm better, and now our algorithm is linear with a time complexity of O n. N being the size of our array. Our algorithm is now linear, and we actually can't do better than this. I understand that this might be confusing, but you can rewatch this part over and over again to understand how this second pseudocode works. Now in the next video, we will be converting the efficient pseudocode, the one with the dictionary, into code. But before then, I would like you to go over this again and again and make sure you understand it, and try to convert this pseudocode to code before watching my next video. Thank you very much, and I'll see you in my next video.